Okay, so let's keep working through chapter 1.3. We need to talk about how we're going to go about designing our experiments. So the key elements of experimental design can be control, randomization, and replication. So again, these are our key elements. We want to think about control, think about randomization, and think about replication. Okay, so what is control? We want to control for effects other than the one being measured. Right? So what do we mean? We don't want to pick up confounding variables. Sometimes you guys will hear these referred to as lurking variables. All right, so these occur when an experimenter cannot tell the difference between the effects of different factors on a variable. All right, there was a famous experiment done back in the, I want to say the early 80s that showed that, the ho-hum of the study said that women who breastfed their children had children with higher IQs. Okay, so what they were hoping to show was that the breast milk itself led to higher IQs. But there's all kinds of confounding variables, right? We could have socioeconomic status. We could have education. All right, none of these were controlled for. All right, so that's an example of a poorly designed experiment where we certainly had confounding variables. Okay, so here a coffee shop owner remodels her shop at the same time a nearby mall has its grand opening. If business at the coffee shop increases, it cannot be determined whether it is because of the remodeling or the new mall. So here we have a situation where two things are happening simultaneously. So we're not going to be able to say what's in fact increasing the business at the coffee shop. Okay, still within control, we want to talk about the placebo effect. Okay, so this is kind of like confounding variables, but again, something else what we want to control for. This is where a subject reacts favorably to a placebo when in fact he or she has been given no medical treatment at all. Okay, so I could have 20 of you, I tell all 20 of you I'm giving you Adderall, when in fact 10 of you I'm only giving you an Advil. Okay, well, because in your mind you are thinking that you're getting Adderall, maybe you act amped up and everything, when in fact you're just taking an Advil. So that would be an example of a placebo effect. We also have something within there called blinding, and this is a technique where the subject does not know whether she's receiving a treatment or a placebo. So in my cheesy little example here, this would be where the 20 of you that I'm running this test on, you don't know whether or not you're being given Advil or Adderall. I could just say, I'm giving you Advil or Adderall. You don't know, okay? That you could see how by not knowing, that might help control for the placebo effect. All right, and then there's something actually called double blind. That's where in the experiment, neither the subject nor the experimenter knows if the subject's receiving a treatment or a placebo. So this would be where I've mixed them up, the pills look identical, and I have no idea whether you are getting Advil or Adderall. All right, let's talk about randomization. So we've talked about control and how we need to control for confounding variables and how we need to control for the placebo effect. All right, so now with randomization, this is a process of randomly assigning subjects to different treatment groups. Okay, random is a big word in statistics. Okay, so let's talk about what is a completely randomized design. This is where subjects are assigned to different treatment groups through random selection. Okay, a lot of times we'll use randomly generated numbers to do this, to assign subjects to different treatment groups. We could also, though, have a randomized block design. This is where we're going to divide subjects with similar characteristics into blocks, And then within each block, randomly assign subjects to treatment groups. So maybe I want to look at something with my stats students, and I'm going to first divide you guys into males and females. And the females I'm going to assign either to one of my treatment groups, and my males I'm going to assign to one of my treatment groups. That would be more of an example of a randomized block design where I'm using gender as my blocks. Okay, another example. An experimenter testing the effects of a new weight loss drink may first divide the subjects into age categories. Then, within each age group, randomly assign subjects to either the treatment group or the control group. Okay, and so here in this diagram, we can clearly see, what I'm talking about by a randomized block design. All right, we could also have something called a matched pairs design. This is where subjects are paired up according to a similarity. Okay, one subject in the pair is randomly selected to receive one treatment while the other subject receives a different treatment. All right, so for example, all you guys take a pretest. All right, then I'm going to randomly assign students to one of two groups. Okay, group 1, 30 students, does not get a practice exam, whereas group 2, the same number of students, does get the practice exam. And then we're going to compare the exam results. Okay, so again, what do we have here? I'm just splitting you guys up. It's like one goes into a practice exam, one goes into no practice exam. All right, two completely different treatments, and then I want to compare your exam results to see, hey, does this practice exam really matter? Does it help or not? All right, and now let's talk about replication. Replication is the repetition of an experiment using a large group of subjects. All right, so what are we talking about here, guys? To test a vaccine against a strain of influenza, 10,000 people are given the vaccine, whereas another 10,000 people are given a placebo. Because of the sample size, the effectiveness of the vaccine would most likely be observed. All right, this is where we talk about a denominator. Our denominator is 10,000 people in each group. All right, if this vaccine is really working, we're going to see it in those 10,000 people that get the vaccine. All right, so let's talk about another example. A company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify a potential problem with the given experimental design and suggest a way to improve it. All right, so let's go through this example, and again, this is going to be something similar that you guys are going to do on your own, or in lab, I should say. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender. Females are given the new gum, and males are given the placebo. After 2 months, the female group has a significant number of subjects who have quit smoking. All right, think about it. Any potential problems here? All right, well, the groups are not similar. All right, the new gum may have a greater effect on women than men, or vice versa. All right, so here, let's go back. I'm going to skip back here all the way to our randomized block design, okay? So and grab my pen. Let's focus right here, guys. What are we going to do? We're going to divide subjects with a similar characteristic into blocks. Well, in our experiment with the smoking example, we do that. We have males and we have females. And then within each block, randomly assign subjects to treatment groups. And so for our example to be a good experimental design, we would need girls where some do use the gum and some do get a placebo. And then for our males, we would need some to try the gum and some to be given the placebo. Do you see the difference between what would be a sound or good experimental design of randomization block versus what happened here where just the females got the gum and all the guys got the placebo? All right, so what could we do then? The subjects could be divided into blocks, just like we said, according to gender, but then within each block, we'll split them up, where some women chew the gum, other women get a placebo. Similarly, some males get the gum, whereas some males get the placebo.